Here we have a SAT math problem. Okay, let's go to the question. If x equals to 2nth root of 4 times x to the power of n positive 21, where n is an odd positive integer constant, what is the value of x to the power of n? Okay, in the given equation, we have to find the value of x to the power of n. Let me write the given equation as it is. That is x equals to 2nth root of 4 times x to the power of n positive 21. On the right side of the equation, we have radical with the index 2n. Now to get rid of this radical, we have to raise both sides of the equation to the power of 2n, which is the index of the radical over here. Okay, now let me raise the stuff on the left side. That is x is raised to the power of 2n. Let me do the same thing on the right side as well. That is 2nth root of 4 times x to the power of n positive 21. It has to be raised to the power of 2n. Okay, here this 2n and the radical with index 2n will cancel out. And on the left side, let's consider the exponent we have over here, that is 2 times n. Whenever two values are multiplied at the exponent, one of the values can be taken as the exponent for the existing base, and the other value should be taken as the exponent for the whole stuff. That is the power of a power rule in exponent. Okay, now let me take this value n as the exponent for the base x, then we get x to the power of n, and we can take the other value 2 as an exponent for the whole stuff. On the right side, we have 4 times x to the power of n positive 21. I find x to the power of n over here and also here, and our aim is to get the value of x to the power of n. So now let me assign a new variable z for x to the power of n. Now we can plug in the z for the x to the power of n over here and here. Then the equation will become z square equals to 4z positive 21. Now let me subtract 4z and 21 from both sides of this equation. Okay, here I am doing this to get this quadratic equation standard form. That is, I am going to get everything on one side of the equation and 0 on the other side. Okay, here this positive 4z, negative 4z will cancel out. Positive 21, negative 21 will cancel out. I am getting z square negative 4z, negative 21 equals to 0. Okay, if I want, I can use Desmos to solve this quadratic equation. It's a pretty easy one. We can solve this quadratic equation by factoring. For that, we have to multiply the constant of negative 21 by the coefficient of z square, that is 1. 1 times negative 21 is negative 21. Now I have to get two factors over here, so that the product of two factors equals to negative 21, and the sum of the two factors equals to the coefficient of z, that is negative 4. I think negative 7 and positive 3 will work. When we multiply them, we get negative 21. When we add them, we get negative 4, which is a coefficient of z. Then to get the two values of z in this quadratic equation, we have to change the signs of these two factors. When I change the sign of the first factor, I am getting positive 7. When I change the sign of the second factor, I am getting z equals to negative 3. Okay, here I got two values for z, 7 and negative 3. Now let's replace z by the original stuff, that is x to the nth power. Then we get x to the nth power equals to 7, and here we have x to the nth power equals to negative 3. Okay, here I got two values for x to the nth power. Can I consider both the values for x to the nth power, or do we have to consider only one of them as the value of x to the nth power? For that, we have to verify the solution. Now let's consider the information we have over here. N is an odd positive integer, and when I consider the second value of x to the nth power, that is negative 3, here n is an odd positive integer, and also the value of this x to the nth power is negative 3. Then what must be the value of x? Then x must be a negative value, so that when a negative value is raised to the power of odd negative integer, it will result a negative value. Okay, when x takes a negative value, then we have a negative value on the left side of the equation. So that is here we have a negative value, but already we have a positive value on the right side of this equation. Even when I plug in this negative 3 for x to the nth power, here in front of the radical we have positive sign. So when I consider the second value of x to the nth power, so I am getting a negative value on the left side, positive value on the right side. So it's not true. So we can reject this value. Okay, here x to the nth power equals to positive 7. We know that n is an odd positive integer, then x must be positive, so that the value of this one will be a positive value. So clearly x is a positive value. So when I plug in a positive value for x over here, on the left side of the equation I am getting a positive value. Already we have a positive value on the right side of the equation. Therefore, the value of x to the nth power is 7.